All right, folks, welcome, welcome. I'm going to mute everybody. Just going to mute you guys. If you guys have something to say, please feel free to unmute yourself, and say something or what have you. But yeah, tonight's topic, we are going to touch on STP. Okay.
Hello,
So
David. Can you hear me?
yeah, I can hear you.
Oh, okay, okay.
Yeah, we all good, all good. Um, so we're going to touch on, oops, whoopsies. We're going to touch on that, take a look at it. And yeah, that's it. So let's go ahead and get started. So, spanning tree, right? Spanning tree protocol, okay? What is its job, right? One of the three main functions of a switch, I should say, not major. Three main functions of a switch: learn MAC addresses, forward packets based on their destination MAC address, okay? Prevent loops, layer two loops per redundant length using spanning tree. Okay. And so with spanning tree, right? I know you guys looking at a blank screen right now. We'll start diving deep into the lab. Spanning tree, they use what they call a spanning tree algorithm, right? And what they do is they go ahead and create a topology database of a network, right? And so SPA, right, spanning tree algorithm, it'll go ahead and it'll talk with other switches, right? And it'll receive different frames called BPDUs, and we'll touch on that in a few. We'll take a look at that in Wireshark. And it'll say, hey, based on this criteria, based on the information that you're sending me and the entire topology, based on what you're sharing, I'm going to go ahead and place certain interfaces in a forwarding state and other interfaces in a blocking state. Why? Because with spanning tree, the goal is if we have redundant links, I only want one-way flow of traffic. That's it. Okay. But for actual, ports to be placed in different states and roles, what have you, there's a couple of criteria that needs to match. Okay. Number one, all switches in the network need to elect a root switch. Okay. Now take notes because this is going to help you with that challenge. Before we take a look at, okay, is this forwarding or blocking? All the switches in the same broadcast domain, right? Same network, layer two network, or what have you. There's no layer three boundary. They need to elect the root switch, right? All working interfaces on that root switch are placed in a forwarding state. So on a root switch, right? Because it's the top dog within the topology, it needs to be available to each other switch. That's why all the interfaces are in a forwarding state, right? And the role of each port is designated. Okay. All right. So, number two, all the other switches, right? Non-root switches, you can call them, or switches that are not the root, however you want to, name it, right? What they're going to do, right, is say, all right, we know who the top dog is. Now we need to go ahead and determine the best path to get to the root switch, right? The port used to go ahead to reach the root switch, right? You're going to go ahead and pick that root port. Then the other ports are going to be either designated ports or blocking port. Okay. All right. So now that's number two, right? What about number three? What's that other criteria, right? On shared Ethernet segments. The hell does that mean? That's a big word, and that sounds like Cisco's terminology, right? Whenever you hear the word shared Ethernet segments, that just means exactly what I said earlier. Devices that are part of the same, that are connected on the same network. There is no layer three router that's blocking them or nothing like that. They're all connected and they all can talk on the same network. So the actual technological term on the shared Ethernet segments, right, between non-root switches, right? So not the root, two non-root switches, they're connected to each other, okay? Those two switches, they're going to choose the best path to reach the root, okay? Right? And they're going to place one port in a forwarding state, okay? Right? And the other port in a forwarding state, right? And then based on them talking to each other, it's going to say, all right, I'm the designated switch of this topology, or this triangle. And I'll show you guys a triangle in a second, right? And so you'll have your root switch and you'll have your designated switch, right? Once you identify that, what's left? There's also one last switch within that triangle of a topology, okay? Now you need to go ahead and change the port roles and state between that. And now if the root switch, root bridge, if all of it's forwarding, okay? If that designated switch, it's forwarding on its ports within the topology, and now it's a designated switch. That non-root switch, we have our root port to the root, but that other port pointing to the other non-root switch or the designated switch, we need to block. And once we do that, spanning tree done its job. We have one-way flow of traffic, and we're not going to have a loop if Louise tries to go ahead and get to Google from an access switch, trying to get out to the core switch. Okay. All right. Let's take a look at how this looks. Go ahead and build out a topology. Switches. Build out a little triangle and do that. By the way, guys, if you guys haven't seen this, is even G. Pretty cool stuff. I like this. This has been serving me good for the past 3 or 4 years. Helped me get my CCNA, CCNP, Fortinet certs, et cetera, et cetera. GNS3, to be honest, it's resource hog and a lot to set up and not a lot of flexibility. Yeah, so if you guys ever wonder about this, I can help you guys set this up. Just need to schedule time. Let's go ahead and get this set up. Boom. Doesn't matter which port. Okay. And let's go ahead and set that up. There we go. Boom. And there we go. Look like that. All right, let's fix the triangle. Let's fix the triangle. This triangle is a little bit dirty. There we go. All right. Before I turn these bad boys on, I want to get some information because I want you guys to even try to, before we turn anything on, right? The goal of you guys being network engineers should be able to converge a topology just with a pen and a piece of paper, right? So that if you guys ever get into a situation, there's a loop in your network, you can write it out and troubleshoot and see and picture in your mind, okay, I know what I need to do. Okay, let me blow this up a little bit more, make it 16. Hopefully that's good, guys. Okay, I'm gonna put the MAC addresses. Let me just, because words mean things. Okay, system MAC for that. Let's go ahead and duplicate that and duplicate that. Okay, just because I know the lab, the only number that's going to change is right here. So switch 2 is going to have 2. Switch 3 is going to have a 3. Okay, so let's take a step back and let's talk about BPDs. Okay, so I told you guys that between these switches they talk, right? And for the spanning tree algorithm to have, they need to be able to communicate, right? And they communicate via these messages, these frames called BPDUs, Bridge Protocol Data Units, okay? And what these are just messages used between the switches to share spanning tree information with each other in order to elect a root switch, right? And so as soon as I cut these bad boys on, they're talking, BPDUs are being shot out. Who's the root, right? And initially, right, each switch is automatically going to think it's the top dog or it's the root switch until, right, it receives a BPDU from another switch, and that BPDU is showing from the other switch, better criteria, right? Maybe the bridge ID, and we'll touch on bridge ID in a second. That bridge ID is better than its own. It's going to say, hey, I'm not the top dog like I thought it was. Let me go ahead and say, hey, that's a top dog, and let me tell my own self, hey, he's the root, right? And then spanning tree algorithm will start doing its calculations. BPDUs will be set between The non-root switches, they'll try to designate who's a designated switch amongst itself, then who's the non-root switch, who of course is going to have that root port and that blocking port. Okay, so a couple of things you're going to see within the BPDs, right? 4 things, right? Probably going to be a little bit more once you see in the packet capture, and we'll only start with just turning on one device for now. But we're going to see the root switch ID, right? The sender switch ID, right? The sender's root cost, and of course the hello timer, the max age, and the 4 delay timers. Okay, why is all that important? Okay, networking is not just at layer 2; it's at layer 3 as well. So understanding that every protocol has, every management protocol, right, that has to deal with the flow of traffic or what have you, like eGrip, OSPF, right? Things like that. Everything has a hello timer, right? A max age timer, a forward delay timer. They're probably called different things, but you guys understanding it at layer 2, then trying to go and trying to learn something like eGrip, OSPF, BGP, right? ISIS, right? You guys going to learn these protocols, right? It'll be second nature when you guys learn it. You guys say, hey, okay, it has both of the same things, and here's why. Okay, so that's the couple of things that we need to know that we'll see in the BPDU, and we'll look at that in a second. Okay, quick note. Whenever I cut this on and I do a packet capture, a couple of things we're going to take a look at. Okay, so just for lab purposes, I'm not going to turn on this because I know switch 1 is going to be the root switch, and I'll tell you why later on. But I'm going to cut on switch 3. Okay, I'm going to cut that on, and I'm going to do a packet capture on gigabit interface 0/3. Let's do that. Doesn't matter at this point. I just want to go ahead and let you guys see the BPDUs. While that's coming up, guys, you have any questions? Okay, take that as a no. All good. So we'll wait for this packet capture to come up. It might take some time. We may have to restart it because it is booting up. Let's pop this bad boy. There we go. Okay. All right, while we wait for that. There we go. That's the things I like to see. Switch is booting up. All good. At this point, it should be already sending some stuff out. Let's go ahead. Okay. There we go. That's what I wanted to see. Okay. Data link type Ethernet. Of course, we can catch other protocols. We'll start with Ethernet. We just want to capture the wire. And let's wait for it to boot up. Thank you, Even G. Okay. All right. So a lot of layer 2 stuff we see got going on. Let's go ahead and switch the protocol to STP. All right. Let's break this down. Boop. Okay. All right. So a couple of things we see here, right? Let's break this down. Let's take our time. And guys, please ask questions. Okay. If something doesn't make sense, it's all good. Okay. So we have our protocol identifier, right? This is telling us this is spanning tree. Okay. There's other type of different flavors of spanning tree, I should say, right? So this value can change. Okay. We got protocol version identifier, right? We have BPDU type. It's a configuration. There's different types of BPDUs, and we'll touch on that a little bit later. Okay. We have BPDU flags, right? We don't see a TCN. We'll touch on that a little bit later. There's no topology change acknowledgement, right? For this one, it's just a simple BPDU that's sent. Like I told you guys, when we boot a device up, it's just going to send a regular BPDU announcing itself from a layer 2 standpoint on the network. Layer 3, there's a way to announce yourself on a network, but again, we'll touch on that in the future. Okay. So we got our root identifier and we got our bridge identifier. Okay. And if you guys take a look at this, okay, if you guys take a look at this, let's see if we see some commonalities. Okay, right? We're looking at layer 2 for now, right? IEEE 802.3, right? That means Ethernet. Source, right? It's coming from this, right? We see it's coming from the third interface, right? On this switch, okay? Right? But the system MAC address is 50 colon 00 colon 00 colon 03 colon 00 colon 00. Okay, so the root identifier is this switch. Okay, so we have three things. We have the, of course, the give me 1 second. Sorry guys, got a text from boss man. Okay, all good. Sorry. Got a change I'm doing tonight, so I'm trying to multitask. So we have a couple of things here. We have a 2-byte priority field, right? So we have the root bridge priority, right? 32,768. A couple things about this number. 32,768 is always, if you don't change anything, this is the value by default. This is always going to be the priority on the switch by default. Okay? Right? If you don't change it, all switches will have that. Okay? And remember that when it comes to the election process. Okay? The root bridge system ID, right? Right? The system ID extension, right? This is typically, this value is mirroring the VLAN. Okay? So if it's VLAN 9, right? It'll say system ID extension 9. If it's VLAN 10, root bridge system ID extension 10. Make sense? Right? And so this 2-byte priority field, right? There's a total value, right? That total value is the priority plus the system ID makes, right? Makes this priority field, right? So it's, let's say we have VLAN 9. We don't change the priority, but we have VLAN 9. 32,768 plus, right? And it's VLAN 9. So we add 9, and it's going to be 32,777, if I'm correct, 777, right? And so that would be the priority field, right? That would be the priority ID, right? Now, we see this, right? It's the system MAC address, right? And this is the 6-byte system ID, okay? And so this is just the MAC address for this switch, right? Combined together, right? All these three fields is the bridge ID. Every switch is going to go ahead and once I turn all these devices on, once they choose their root bridge, they're going to have this information via BPDUs. Okay, it's part of the election process, but this is what makes a bridge ID up, right? We have BPDUs, the messages that are used to communicate within each other. Then we have a bridge ID. This is how we identify each switch. Okay, and so again, these two would be together, right? You would add these two together, right? But you wouldn't add this. And there's a reason being, again, because of the election process, okay? So there's that. Now let's take a look at something, right? Remember I told you guys earlier, if there's no other switch in the environment, every switch, as soon as you turn it up, it's gonna assume that it is the root, okay? So of course you guys can see, right? The root identifier is itself. The bridge identifier, right, is itself, right? What are these two different fields saying, right? This is telling you this current switch, the bridge identifier. The root identifier, it can be a different switch within your topology. This is not always going to be, always going to reflect the switch that you're on, okay? So if you're looking at a packet capture or you're taking a look at a show command, you'll see the root bridge ID, maybe to be something different. If this is not the root, it'll definitely be something different. But of course, the bridge ID will be your own switch. And we'll take a look at that a little bit later. Okay? Simple enough. Let's keep going. All right? And like I told you guys, you have your different timers. Forward delay, hello time, max age, message age. Okay? Really important things to learn to comprehend before we move to layer 3, before you guys move to layer 3 and start understanding these routing protocols. Again, fundamentals for each layer, okay? So let's go ahead and break one more thing down before we jump into cutting on these other switches, okay? So there we go. So we talked about bridge ID, we talked about BPDs. So all that is to say what, right? That total bridge ID, right, sending between each other, the lowest bridge ID will become a root switch, right? And so first is going to look at the switch with the lowest priority, right? Lowest being better. If the priority is the same, right? Meaning the priority, which is if we go back, meaning the priority in the system extension, if that is all the same within this topology, then it's going to look at the MAC address. What's the second criteria? What's different, right? So it's going to take a look at it and see, what's the difference? What's the lowest number? Oh, the lowest number is 1. Oh, okay, perfect, right? That's my root, okay? And so a couple of things you need to understand about MAC addresses if you guys don't already know. It's a hexadecimal numbering scheme, okay? So take some time and take a look at it. I'm actually going to go ahead and Google hexadecimal numbering scheme so you guys can actually take a look at it in live. So give me 1 second. Hopefully this is easy. Okay, perfect. All right, so first things first, right? Take a look at it. Hexadecimal numbers, they go all the way up to, right, F, okay? So first they go from 0 to 9. After 9, it's no double digits. It's going to go straight to A, B, C, D, E, and F, and it stops right there, right? Okay, so it's 15 characters in total, right? Of course, you can, one hexadecimal number, you can transfer that into binary, et cetera, et cetera. I will paste this link in the chat. I believe this will be good for you guys to have. Just, you can save in your bookmarks or what have you. But this is the hexadecimal, right? 0 is the lowest, F is the highest, okay? With that being said, okay? With that being said, right? Who would be the root bridge? I'll leave it open for the next 60 seconds. I'm looking at my stopwatch for anybody to open. Who would be the root bridge and why? Mind you, I did not change anything to VLANs, nor did I change anything to the priority on these switches.
Switch
right?
1 would be.
Okay, why?
So if priority is the same,
Okay.
then if nothing else was ever affected, it would be by lowest MAC address. And
Okay.
since it is by 50.0.0.0.1, then 0.2, then 0.3, that since the switch 1 has the lowest MAC address, that's the one that's going to be elected as the root.
Amazing.
I knew that too.
Amazing. Simple as that, right? We don't have to add any extra fluff. The first 6 bytes of the MAC address are all the same within the topology, right? That first byte, after that, what's the difference? 0, 1, 0, 2, 0, 3. What's the lowest? Switch 1 has the lowest. Boom, it's done. So switch 1 is the root, okay? All right, so let's test that. Let's test it, okay? We still got a packet capture going, blowing up resources on my damn PC, okay? Let's see what happens. I cut this bad boy on. It's going, it's going, it's going. Okay. New stuff is coming in. Okay. Let's see packets. Let's go. Okay. Some different stuff. Let's take a look. All right. Let's see. Let's see what changes. Oops, sorry guys. Of course, I'm clicking all over the place. Let's just see if switch 1 should be booting up by now. There we go. Okay, all right. Let's take a look. All right, and guys, keep an eye on it with me. Let's see if anything changes. Oh, okay. See a few things. We do see a different BPDU, right? We see a different source. Okay. All right, for frame number 425. Okay. Let's keep going. We're receiving that. We're receiving that. All right. All right. So we have, so again, we're capturing on gigabit 0/3, okay, on switch 3. And we're seeing a different BPDU, okay, for a different bridge, for a different bridge or a different switch, okay. Let's wait for it to converge. I can see there's some TCNs, topology change packets that are being sent. So let's wait for it to converge. And we'll take a look at a BPDU from switch 3, and we'll see. I'll show you guys the difference of seeing the root identifier and the bridge identifier. Okay. Okay. And while we're waiting, we can actually pop into switch 3. Let's take a look at that. Okay. So, like I was telling you guys before, okay, you're gonna see the bridge ID and the root ID. Okay. So that command would be who's in this? Lou, help me out. What's the command to look at spanning tree? It's leaving my mind. It's been a long day.
Isn't it showed spanning dash tree?
There we go. Thank you. Okay. So we see a difference, right? So exactly what I was telling you guys, right? That root ID, it's based on who's the root. It doesn't actually mean this switch. This is switch 3, right? So the root system ID is of course switch 1, right? And of course this switch, right? Because this is something that a lot of people skip over and all that stuff. This switch, here's this switch's system ID, right? So this is the root, whether that's this switch or something else, and this is this switch. Okay. Of course, we see our different timers. We'll touch on that in the future. We see our different port states and roles. We will touch on that in the future. Just wanted to let you guys see it, how it looks from a CLI standpoint. Okay. Now let's see if we can find a packet of a BPDU from. Okay, let's see if we see a BPDU from this switch. Okay. You know what? Let's capture on a different interface because I don't see anything at this moment. So let's pop that and let's capture on this. There we go. And so while I'm capturing on that, because hopefully it'll go ahead and it's sending BPDUs out of all of its interfaces, but it's BPDUs that it's sending, it's going to say, hey, the top dog is switch 1, not me. Just wanted to let you know. Let's go ahead and take a look. Okay, perfect. So we found exactly what I was looking for. See that root identifier, right? So switch 3 is saying exactly what I said. Hey, the root is switch 1, but the person that's telling you this is switch 3, right? I'm telling you about the topology. This is how, if we go take a look at it, each switch, right, within a triangle, right, learns about the entire topology, right? If there's no layer 3 boundaries, it's all going to send its information amongst each other, okay? Hopefully that makes sense, okay? Let's go ahead and stop this packet capture. I think it makes sense from there. And let's go ahead and cut on this switch, okay? So, quick review, like I told you guys, bridge ID. Bridge ID composes of the priority, right? The priority and the system value, of course, whether it be a VLAN, and the actual switch's system MAC address, okay? The first selection process is, of course, the priority. If that's the same, it's going to go ahead and go to the MAC address, okay? Of course, you can change it, right? You can change the priority. You can also change the you can change priority, and and the priority being either you can change that value 32,768 Okay, you can't change the VLAN because it's going to go ahead and correspond with that. Okay, you can't change the system MAC address as well. Okay, but you can modify that so that one switch will have a lower priority than something else, and we'll touch on that in a few. Okay, so again, that's the root switch election, right? What else do we have to do, right? We need to go ahead and make sure that we are optimizing, and this is what the SPA algorithm does, right? The spanning tree algorithm does. It now needs to go ahead and converge the other part. It needs to go ahead and say, all right, these non-root switches, I need to go ahead and pick my root point, right? Because first I need to identify how to get to this root, right? Because this is my way outside of the network to my ISP, to Google, to Minecraft.com, right? To Halo, whatever you guys like to do, right? That is going to be your way out. Okay. And so it's another election process, right? And so just like electing the root bridge, right? These non-root switches, they're going to go ahead and go through an election process themselves, right? To go ahead and choose the root port, they're going to say, what's the lowest neighbor bridge ID? Okay. So with basically whoever my neighbor is, who has the lowest bridge ID. Okay. So it's going to go ahead and choose that, right? Who has the lowest neighbor port priority, right? And who has the lowest neighbor internal port priority. Okay. And so once it does that, right, it's going to go ahead and say, okay, perfect. I'm going to go ahead and choose the best path, right? And just to circle back, I'm telling you things, and the things I just told you, those are tiebreakers, to correct myself. The first part, right, to choose a root port, it's going to choose based on the cost, right? The interface cost, the speed, it's going to go based off of that and say, hey, what is the shortest cost to get? Not the quickest connection, right? If we have a direct connection, that does not actually mean that is the lowest cost. And I'll touch on that in a few. It's going to choose the. Say it again.
Can I give a crack at it?
1 second. Let me finish explaining the theory. I got you. Okay. Thanks, Lou. So again, it's going to go based off of the lowest cost. Okay. And there's different costs for different speeds of interfaces. Okay. So let me explain that. And then Lou, I'm going to have you give a crack at it. Okay.
Yep, no worries.
Okay. 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 All right. So what I leave it out to you guys is the speed of an interface and the cost. Okay. And so these are the default port costs. If you don't change anything on the interface or what have you, these are the legit costs, right? As you guys can see, these interfaces are gigabit interfaces. We can go ahead and verify if we hop on the switch. We would show interface. And we'll do anyone gigabit, right? 0/3, right? Oops, 0/3, right? We trust, but we verify, right? We take a look at it, okay? And so, of course, hardware is telling us gigabit. Bandwidth is, of course, in kilobits, right? That translates to 1 gig, okay? All right, and if we do a show interface brief, whoops. Interface. Uh-oh.
Dave, you tired?
No, I'm just waking up, man. Been a while. Well, you know what? Show IP interface. There we go. Look at me figuring things out. Okay. And of course, you can see interface. Of course, if you want to ever confirm a speed of interface, I always tell folks run that command first, check the actual bandwidth, use a converter if you can't convert it in your head. We're all human. I sometimes need a converter, right? Put this in somewhere in Google, you convert it, what is that? 100,000. Yeah, let's do it together. Convert bits to, okay. Okay. So boom. I believe that is right. Yeah. So 1 gig. Hold on, make sure I pick the right thing. Yep. Cool. Cool. So
You're just off by 1 0.
I'm off by 1 0. That's what I figured. Do I need another one? 1, 2, 3, 4. Yep, I am off. Thanks, buddy. Boom. Okay. So we can confirm, right? Trust but verify. This is a gigabit interface, right? Right? You do that conversion, boom. And guys, I love to verify. Nobody knows everything. If it's one thing I can ever leave you guys with, please trust but verify, even with yourself. If you're second guessing yourself, Google it. Use Google Foo. It's encouraged. Okay. All right. So let's keep going. So we have the cost, right? We have our speed and we have our cost. We have gigabit interfaces. Okay. Lou, now it's your time to shine, right? For all of these being gigabit interfaces, we confirm the speed. What is my cost for each link?
It's gonna be 4.
Okay. So it's going to be 4. With that being said, go ahead and put that there. All right. So all the interface is going to be 4, right?
Yep.
Assuming that I didn't make any change, correct?
Correct.
Awesome. Go ahead and put that there. Okay. All right. So we have our cost set. We have our costs put into our topology, right? So we can read it a little bit better now, right? We can actually choose our root ports, right? So Lou, I want you to take a crack at it some more. How would, from switch 2, I'm going to leave switch 3 to somebody else. How would switch 2 determine its root port? And which port would be the root port and why?
So pretty much the costs are the same. So
Remember, you're on switch 2.
sorry, gig 0/2 would be the root because it does have a directly connected to the root bridge.
That's not the reason. Okay. So, because I can do this, let me show you. And Lou brought up a good point. And Lou, I'm glad you said that. I can do this. Okay. I can go ahead and do that. Just because it has a direct connection, it's going to win? Absolutely not. Spanning tree, it picks its root ports. These non-root bridges, these non-root switches, pick their root port based on cost. So if this has a value of 25 on that link, guess who's going to be the root port? Gigabit 0/0. Why? To get to the root, 4 + 4, 8. I'll take that way. That's faster than taking 25.
Right, with the lowest cost.
That makes sense?
Absolutely.
Okay. All right. Let's change this back and fix it. Lou, thanks again. And of course, that was a good answer you said. No matter if it was wrong, because again, I wanted to make that point to everybody. Just because it's a direct connection does not mean, right, that's going to be the root port. Okay. So who can I pick on next for switch 3? Who can I pick on next?
I'd take a stab at it if I could.
Oh shit. Okay. All right, Pat. You're on. Switch 3. Who's my root port and why?
All right, so switch 3. I haven't done this in a while, by the way. So
Okay.
switch 3 root port is going to be GI 0/3.
Okay.
And the reason to that is because it's the lowest cost to the root bridge.
Okay. And what are the costs? What's one cost versus the other? Explain
So
that.
it'll be 4 if we go from that GI 0/3, and it'll be 8 if it goes out from the GI 0/0 because 4 to switch 2, and then from switch 2 to switch 1, it'll be 8. The distance will be 8.
Simple as that.
Or the cost. Sorry, cost.
It's all good. It's all good. I know what you meant. Exactamundo. That's it. No other fluff. No nothing else. That's it. Right. So thank you, Lou. Thank you, Pat. We have our root ports. Right. I hope you guys know what's coming. You guys, I'm going to pick random people to help me converge this topology. Okay. So I'm going to label it my root port. Okay. Going to label that. Put that right here. That's fine. Right. So we have our root ports. Right. So now, right, we need to go ahead and pick designated ports and a designated switch. Okay. Remember what I told you guys, right? Shared Ethernet segments. Okay. What the hell does that mean? That's a big ass word. Okay. Excuse my language. I do cuss a lot, but enjoy it because you guys are in the field. And this is how I get a point across. So I do apologize. Hopefully this video is not for kids. Okay. So let's go ahead and touch on it. All right. So we have, let me get my handy dandy pencil. We have our root ports, right? And let me change that color. The root is going to be yellow. It's the king, right? We have our root ports. Okay. And let's make that point of shared Ethernet segments. Okay. So between a switch, right? If we have a link between two switches, that's a shared Ethernet segment. Why? Because there's a link between two switches and they're in the same broadcast domain because they can communicate over one link. That is a shared Ethernet segment. Okay. So whenever you hear that big word or anybody say that shared Ethernet segment, it's a connection between two switches, right? Okay. And again, it only applies to switches because there's multiple ports on a switch. Okay. Assuming if they're on the same VLAN, right? Let's say we have 14 servers on a 24 port switch. They're all on the same Ethernet, shared Ethernet segment. Make sense? Hopefully it does. Let's keep going. I'll go ahead and get my eraser and let's go over this selection process. Okay. So we have, right? We have criteria to choose the designated switch and the designated port. Okay. Here it is, right? The switch with the lowest cost to reach the root becomes the designated switch, right? If there is a tie, the switch with the lowest bridge ID becomes a designated switch. Okay. So Makivia, help me out. So we have switch 2 and switch 3. Okay. We have switch 2 and switch 3. Based on the criteria that I said, right? We're trying to select, right? Within this triangle, within this redundant topology, we're trying to select the designated switch. To select that, I'm going to repeat it again. It's the switch with the lowest cost to reach the root. Let's take a look at that first. Switch 2 has a cost of 4. Switch 3 has a cost of 4. So between each other, between their shared Ethernet segment, between each other, they're telling each other, oh, bro, to get to the root, I got cost of 4. Switch 2 is saying, oh, to get to the root, I got a cost of 4. Now we need to go ahead and go to the tiebreaker. The switch with the lowest bridge ID becomes a designated switch. With that being said, Mikevia, which switch will be the designated switch and why?
Would it be switch 2?
Why?
Because it has the lower MAC address.
Boom.
Show you right.
Boom. That's it. Keep it simple.
Thank God, because I knew you were gonna call on me. I knew it. God.
All right. So that's our designated switch, right? And so with that, right, and if you guys don't know it, so I'm going to walk you guys through, right? We need to go ahead and assign a designated port, right? And so since we're going to be a redundant switch that's also going to be forwarding traffic, we're going to go ahead and say, hey, we need to go ahead and forward traffic, right, on our port as well, right? We need to go ahead and do that, right? But with spanning tree, this is the only non-root switch in the topology, right? So to prevent loops, spanning tree is going to say, oh man, I'm I am not the root nor the designated switch. To create a loop-free topology, I need to go ahead and block on this port. Okay? So that's what it's going to do. That switch is going to say all these switches are going to send BPDUs, do this selection process, right? And once it does it, it's going to say, oh, okay, all right, I know who's going to be the designated switch and all that. And it's doing all that in the background, right? You're not going to see all this happening in real time. This happens in milliseconds. Soon as if you cut 3 switches on at the same time, right? They come up, boom. They're going to do the election process before you can even see how it went down. Now, we can make changes or what have you and see it in real time, right? But this is a converged topology. Okay? This is a converged topology. Does that make sense to everybody?
Yep.
Okay.
Yep.
Yes, sir.
Okay. 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 Now this next section, this is just fun, us having fun or what have you, right? We can make changes. We can make changes to this topology. We can say, I want another switch to be something, right? Let's go ahead and dive in that. Okay. Jump into switch 2, right? Let's do some verifications. All right. We'll verify a few things first. So spanning tree. Okay, perfect, right? So let's verify our topology, right? This is the designated switch. We have no switch that is in a blocking state, right? Let's go ahead and check switch 3. Let's make sure that Pat, Lou, and Mykevia make sure they converge me properly. Trust but verify. Boom. Right? So we are blocking on the exact port, right, that we stated. All right. And so, yes, Solo, I actually did mention that all the ports on the root switch is forwarding, right? Because it has to be highly available throughout the entire spanning tree topology. Okay. So thank you again for sending me that and reminding me. But yes, I did say that in the beginning. Just a good reiteration for you guys that a root switch, all of its ports is going to be in a forwarding. It's always going to have a forwarding state, right? And the role is going to be designated, okay? On a root switch. And we'll take a look at that in a second, right? But here we can go ahead and confirm, right? Our conversion, right? Thank you, Pat, Lou, and Mykevia, right? We see we're blocking on switch 3. It's the non-root switch. It is not the designated switch, neither, right? Nor the root switch, right? So it's blocking, right? And we are forwarding on a designated switch. So we're good, right? Everything matches up. And let's go ahead and pull in switch 1 too. Let's take a look at that and let's confirm what Solo sent me. There we go. Let's go ahead and clear up the drawings. Looks like my niece been drawn on here. Okay. Let's go ahead, take a look at that, and let's just confirm. Boom. Right? This is the root. Right? So like I told you guys, we do that show command, it's going to show us, right? It's not going to be always, but if the switch that you're on is actually a root, it's going to say from a Cisco standpoint. Let me make sure I say that. There's different vendors out there, but yeah, we're on Cisco and we're talking about the CCNA for now. Okay, so that matches, right? And like Solo went ahead and said, and of course I said in the beginning when we started, the root bridge is always going to, all of its ports within this redundant topology is going to be forwarding. Why? Because it needs to be available to the entire network. Okay. So it's forwarding and the role is designated. Okay. We would touch on roles and state in the future. I just wanted you guys to be able to make sense of the spanning tree algorithm, the criteria, some of the terminology, right? From a fundamental level, right? And we're going to go ahead and have a little bit of fun here, right? So switch 1 is the root, right? It's the root, right? Can we switch it up? Can we switch it up? Well, there's a few ways we can do so. There's a few ways. So switch 1 is Lou's switch, okay? Lou's the king. He's the root bridge, okay? Mykevia is the designated switch, okay? All right. Pat, bro, you're the non-root switch. I'm sorry, bro. But
Damn.
Pat, you work so hard. I'm going to go ahead and give you a promotion, right? We're going to promote you to the root bridge. Okay. How do we do that, right? So let's hop on to switch 3 and let me do this. Help you guys get a good visual. Hopefully that is enough. Bring all these back up. Let me make this part a little bit smaller. Yeah. Okay. All right. Make that part a little bit smaller. Oops. That'll work. Okay. All right. And let's pop. Okay. All right. That looks good. All right. And let's pop, right? So we're not going to do a Wireshark this time, but we are going to make a change. Okay. And we're going to see once we make a change, does it actually push that change, of course, based on the theory that I explained to you guys. Are those BPDUs getting to the other switches? And based on the theory, it should. And now the value of the root ID should change for each switch. Just to, of course, verify first, on each switch, we see that root switch is pointing towards switch 1. So it's pointing towards Lou switch. So Lou is the king right now in this redundant topology. Let's go ahead and promote Pat, okay? So let's go to global config mode. I'm gonna put config to your configure terminal, right? I'm gonna put the command spanning tree. I like doing question marks because I don't walk around with commands in my damn head, okay? I always implore you guys to use the question mark. So we put spanning tree, right? We want to make an edit, a global change to spanning tree, right? So I want to go ahead and make a change to each VLAN, right? I can identify each VLAN, right? I'm going to go ahead and put all the VLANs, right? 2094, I believe. Guys, feel free to correct me, right? So 2 ways to do this. We can go ahead and like I told you guys, manipulate the priority, make it a lower priority, okay? Priority being this, right? We can manipulate that. Or there is a command, right? A macro, sort of say, okay? To where we can go ahead and say, hey, we'll go ahead and say for this switch, for Patrick's switch, we can just put the command root, right? And we can put primary, and it'll actually do its job and set for all VLANs, based on my command, all VLANs, set this has the root, right? What is that going to do? Okay, let's take a look. Let's look at spanning tree. What do you guys see?
Now the root.
Okay, but what did that command actually do here?
It lowered the pardon me, it made the that switch that you what was that, switch 3, the it made it, pardon me, since excuse me, my fault. Yeah, so pretty much if these all switches are running on spanning tree, they made that switch 3 the priority, meaning that making that the whatever port that is on whatever port designated port, whatever port is the root bridge, based on that priority ID.
Not exactly.
Lord.
Not exactly, right? So what it actually did, you're close. What it actually did is that macro, that command, right? Putting it root and then primary, it changed that priority that I got highlighted to a lower priority than the default.
You decremented.
Oh, okay. Okay.
You see what I mean? Because the default priority is this. Like I told you guys, 32,769. I'm sorry, 32,768 plus the VLAN. We're running in VLAN 1, right?
So when it comes to the bridge priority, you can increment or decrement by 4096 then, right? Plus the VLAN?
That's correct.
Yep.
But let's say somebody that's managing the network, they just started learning about switching, BPDUs. Maybe they don't know about of course, to decrement or increment the priority, it goes up by 4096. Maybe they don't know that. Cisco went ahead and enabled it, and there's different vendors, Extreme Networks, Brocade, right? Juniper, they have the same macro. They make it easier for some of us admins, engineers, etc., to where we can go ahead and put in command. We can say, hey, this is the root, and boom, you're done. Exactly what I just did. Okay. All right. Let's take a look at the rest of the topology. Okay. Let's take a look at my Kivia switch. All right. Let's see what happened. Let's see who became now that Patrick is the king of the topology, he's the root bridge. Let's see who became the designated switch and who became the non-root switch. While I'm putting this command, any thoughts?
So, hold on, it's right on the tip of my tongue. Damn, it's been a minute since I've done this. So I'm just gonna throw it out there. So, in this particular, no, you know, it's not gonna make sense, that question. I'll hold it off.
Nope. Go ahead, ask the question. It's all good. We're engineers. We're meant to not ask questions in the proper way.
All right. So Patrick is switch 3, if I'm not mistaken.
That's correct. That's correct.
So with all the switches on, switch 3 now became the root bridge. So now switch 3 throws out a configuration BPDU to switch 2 and 1, correct?
Mm-hmm.
Because there's been a change in the topology. So now switch 2, or actually switch 2 and switch 1 is going to throw a TCN to switch 3. And then switch 3 replies with a config BPDU. I don't know if I said that correctly.
You did. You did. You're almost correct, but you're on the right path, right? So that configuration BPD is going to be sent out on this entire topology, right? This broadcast domain. That TCN is going to be sent between switch 1 and switch 2. Switch 3 already knows. Pat already knows he's the boss. You don't need the switch 2 and switch 1 doesn't need to tell him. It's up to switch 1 and switch 2 to send that TCN amongst each other and then do that election process.
Okay.
Does it make sense?
Yep.
Okay. So we have that, right? So us looking at this, right? Pat is now the root bridge. He's now the root bridge. Mykevia being switch 2, she is now the non-root switch. She's not the designated switch no more. Okay. Lou, right? Switch 1, he is not a designated switch. Okay. Pete, I know you're still there, Pete. Why is that the case?
So,
oh, sorry. I thought you said me.
no, you're good. So you're asking why switch 2 is still the designated switch?
No. Why is switch 2 not the designated switch anymore? And why is switch 1 the designated switch now?
Okay. Just had to verify the question for a second. All
It's
right.
all good.
So why that's the case? It's because since you did alter the original BPDUs, now the switch 3 is now the king. It now needs to do the re-election again because of that little notification. And since the bridge ID and the priority is the same for the other two, it's going to go by the same exact thing of the lowest MAC address. And now that is now the new designated.
Boom. That's it. My man Pete, I knew I can count on you. That's exactly it, guys. That's combined with what Lou said, putting that together with what Pete said. That's exactly it. There was a new sheriff in town, switch 3, said, I'm the root bridge. Now switch 1 and switch 2 have to communicate within each other, right? They look the same, right? They have the same priority, right? Have the same priority. Again, like I told you guys, here's a quick nugget. That priority entails of the priority number and that system ID. System ID always relates to the VLAN, right? So let's say if this was, of course, VLAN 9, you're going to see a 9 right here. Then the actual total number is going to be 9 plus, okay? And we'll actually test that out, okay? But yes, right? It didn't change on this part. So they both look the same at the priority. So the tiebreaker, MAC address, right? Based on the hexadecimal numbering system, right? It's all the same all the way up until here. Okay? All the way up until here. 1 is lower than 2. Lou is the designated switch. My Kiwi is a non-root switch. Make sense?
Yep, absolutely.
But what if I just wanted to go ahead and make my Kiwi the designated switch? You can actually do that. And this is my last tidbit for the day. I don't want to throw too much at you. We're going to go over within Spanish. We're going to go over roles and states at the next session. But if I wanted to make her the designated switch, I can change the priority, or I can reverse engineer some stuff. Let's go ahead and go into global config mode. Okay, do that same command, right? It's going to affect all VLANs. Run through 4093. Okay. Whoops. There we go. And we're going to put root, but we're going to put secondary. What is that going to do?
It's going to convert it. It's going to convert my Kiwi switch from non-root to root.
It's
Is
going to
it?
be the automatically default designated router. So if the root goes down, that's going to be the one that takes over.
Sorry,
Yep.
I did it.
That's one answer. That's one answer. I want you to take a look at the priority between switch 2 and switch 3. And I'm going to do switch 1 again. Look at the bridge ID between
The
all of them.
priority dropped, so this way it is going to be set as the designated, since it's not lower than the than switch 3, but it is
Done right. You're right. Keep going, Pete.
But switch 1 is still higher, so down that one is just going to be the just going to be sitting around doing almost nothing.
Exactly. Exactly right. Right. Remember what Lou said, guys, and this is actually in the book, right? To manipulate your priority for your switch, right? You can change the priority number, but it goes up by 4096. So if you want to make it right, the secondary switch is going to go down by 4096. Okay, 4093, whatever the number is. I may be wrong, right? But 4090 something, right? Something in the 4000s, okay, is going to be that difference, right? So if we see it, right, I put the secondary command on my Kiwi switch, right? We see the priority now is 28672 plus VLAN 1, 73. This is on the switch where I put the command secondary. The one where I put primary, 245777. Okay. So that's the macro. Again, it's making your life easier. You just converge your topology, right? Now going back to what Pete said, right? His other answer. If we lose that root switch, oh, we're good. We have another. My Kiwi is going to be the next boss in charge. She's going to be the next root switch by default. Okay, because of her priority, because of that first criteria. We don't even have to go to the tiebreaker, the MAC address between her and Lou. Okay, does that make sense?
Yep.
Okay, well, this was part 1 of Spanning Tree. You guys know I love Spanning Tree. I put the challenge out there. You know, I'm excited. You guys got until, of course, what is it, next Thursday, next Wednesday, to try to converge it. We will have a session, right? In 4 weeks, the next 2 weeks, we'll talk about, of course, the port states and roles. But in 4 weeks, we will go over converging the topology, who are the winners and what have you. But I just wanted to have this intro session so that it makes sense. Okay. If you guys have any questions, state them now, or we can go ahead and close it.
Oh, good. We're good.
Okay.
I'm good with this.
Okay. Okay.
Yeah, I'm good.
Yep, me too. This is
All
good.
good. Okay. All right.
I think my only question that I want to know,
Mhm.
where I know this is going to be advanced, how does it make those cost calculations? Like, why did gigabit became 4, 10 gigabit as 1, faster than that 19? Where did it come with that?
So the people that created spanning tree, right? You go read the RFC, and I'll send it in the group chat. Go read the RFC. They did that on purpose, right? For each different speed, there's a different cost, right? Making the calculation simple and what have you. Think about it. If we had, I was just struggling with kilobit numbers. Imagine if that was a cost. You try to do it on paper. It's going to confuse you, isn't it?
Okay.
Okay. So they try to make it simple, try to make it easy. Different speeds mean different things. 10 megs, 100 megs, 1 gig, 10 gigs. Okay. All right. So that's what it the hell?
Oh, I'm sorry. I'm so sorry.
Yeah, it's all good. But that's where it came from, right? It came from them creating the technology, spanning tree, and of course, them laying it out. I will send a doc after this. I got you. I'll link it in the video as well. Okay. So good question, Pete.
Cool. Because yeah, every time I was like reading through this, it just sounded like this was just what I call dartboard logic at that point.
Yeah. No, there's a method to the madness.
Okay, good.
Everything you see, OSPF, eGrip, it's for a reason. It's always for a reason. So you just got to read that RFC or read these blog articles of the people who created it. They're still alive. Some of them are still alive today. You can actually send a message on LinkedIn. I did that a lot, and just ask the questions. But yeah, you can do your own research. Look at the RFC. It's a long ass document, but it'll make sense. All this is
All
for a
right,
reason.
cool.
Okay, guys.
I got one question. I got one question before you go.
Sure.
I know when we did set the spanning tree as like a priority for the Switch 3, there was, I think I forgot the exact syntax of the command, but it was like root, like set the root, spanning tree root primary or something. So is there a way that we can set up it being like a secondary type of thing? Because I think you specifically typed in primary, so I'm assuming secondary is an actual command that we can possibly use.
Yes,
Maybe
it
again,
is.
this.
Right here. I just did.
Okay, I must have missed it. I just got out of the meeting, so sorry.
No, it's all good.
Okay,
It's
cool,
all good.
cool.
It's all good. So yeah, and again, just to re-explain what that does, right? We put primary, right? It go ahead and decrements it down to 24,577, right? Right. But if we put if we go ahead and put secondary, it's gonna decrement, right? Switch 2 from the default, but it's gonna make it 4,096, right? Or whatever 4,000 number it is, higher than switch 3. So this doesn't become the root, but it's also the secondary root. Okay.
Gotcha.
That makes sense?
Yep.
Okay.
Perfect. Thank you.
All right, guys. Well, I'm going to eat pizza because I haven't changed tonight for 3 or 4 hours. I'm tired. I'm going to play some zombies. I will see you guys in 2 weeks.
All right.
Later,
All right.
folks.
Thanks for the plan.
Okay,
Take
bye.
care.